The next video for you guys at DAEP will be 8D, and 8D says differentiate between empirical and molecular formula. So if you haven't set up your page, pause this and set up your page. Yes?
There's hundreds.
Hundreds of... Oh my gosh, really? Have you already used the Elodia?
We didn't use it yet, but we're going to look at it this week.
Yeah? Is it being eaten away?
It doesn't look like it, no.
Yeah, they usually eat plants, so...
Because they were eating, like, the grass.
Yeah? Is it all nasty and...
No, it's perfectly clean. Yeah, because I came in, like, I was like, that was kind of dirty over the weekend. But now I was like, it's clean. I didn't do anything. Maybe it's just,
Yeah, they'll start eating on the plants. You might, if you want to mess with it, dump the water out with the snails and just put fresh water in it, but yeah. Yeah. I'd still say student slave labor.
Yeah, well, I told him that. I was like, you guys
Big
want
snails.
snail? Here it is.
No, I say...
Like horror stories with snails. Like, I had a snail. My friend gave me one.
Mm-hmm.
And then I didn't know that they were, like, asexual. And I all of a sudden had, like, 8,000 snails.
Yeah. So what you can do too is say, I'll give you 5 points on your 5 extra points on your test if you'll come pull snails out, throw them in the trash can. Kill snails, yes. Kill them all! You still have some plants over there, some fish over there that are still alive?
Yeah.
That's pretty amazing.
They're doing their thing.
Yeah. Okay, so I'm going to make a video, so tell me what you need.
Tell me what I need?
Yeah, what do you need to work on?
I'm just going to sit in class and finish some math work.
Okay.
All the whole things I got at home, so I'm
Yeah, okay, and I'll bring the banana. I put it in a bag this morning. I don't know what bag I put it in. So, I'll find it today. Okay, so I'm going to make a video really quickly. Okay, so 8D. Gosh, I gotta shut the door.
Do you need the front light on? You want the front light on?
8D is differentiate between empirical and molecular formula. So differentiate, tell the difference between empirical and molecular formulas. So you need just a really straightforward definition for each of those. So the molecular formula is the formula that shows the actual numbers of molecules, numbers of atoms in a molecule. It shows the actual number of molecules or atoms in a molecule. So if we talk about a molecule of glucose, it's C6H12O6. That's the molecular formula. The molecular formula for water is H2O. So we have a molecular formula. Empirical formula is different. Empirical formulas show the smallest whole number ratio. It's like it's simplified mathematically. So C6H12O6 becomes, everything can be divided by 6, so we have C, 6 will go in there one time, so it'd be C1H2O1. Water is as simplified as it can be, so the empirical formula for water would be H2O. Sometimes the empirical formula is the same as the molecular formula, sometimes not. It just depends on the compound you're working at. The empirical formula will always be talking about a covalently bonded substance. So C6H12O6 is molecular formula. And CH2O is the same thing, only it's in the empirical formula form. And you can actually go from the empirical formula to the molecular formula. And that's used actually in a lot of places, especially like if you're interested in crime scene investigation, things like that. They might find an unknown substance and run it through a machine that tells them, hey, it's this percent carbon and this percent hydrogen and this percent oxygen. And from that, you can figure out what the molecular formula is. So what you would do is you would say, okay, if it gives us a percent, we can go from the percent to mass. And you do that by making the assumption that you have 100 grams. Because if it's a percent, it's all going to be in the 100 form. Once you do that, the next thing is you can convert grams to moles. And we'll be using that in this unit here. Yes?
These are little kits I want over the summer.
Oh, it's a little trebuchet thing? Or
Little
what
cars.
is it? Oh, little cars.
Yeah.
Rubber band cars?
Yeah.
That's really cool.
I think they're from Arborside. But we ended up, Rebecca and I both won.
So you just roll it.
Ended up getting 10
Yeah.
kits.
Yeah. If you find them, if we need some more kits, we can try and order some.
So.
Do they roll pretty good? Yeah.
So what I did is I gave them the stuff. I'm like, here, build me a car.
Yeah.
But, and then I built, I'm like, you want me to build one during a class period and show you what it could look like?
Okay, that's really smooth running too. Yeah.
Minimal tools. I mean, I
Yeah.
give them access
It's
to a
nice
box knife to
because
cut the sticks.
if you could have
Screwdriver.
this, do a lab with this, and then you could say, okay, now you're going to make your own.
Yeah.
Yeah. Not with the kit. You've seen what it looks like. Now make
Yeah.
your own.
So that's what
Yeah.
we're doing leading up to for these
Yeah.
last 3 days. So they got their stuff today and they started on them and like, how do we do it? I don't know. Figure it out.
Yeah.
What's this for?
Is this which class?
Physics, regular physics. So, but yeah.
And Scott, what's on the wheel? Rubber. Ooh.
Yeah, big rubber
That's
bands.
nice. Yeah.
That came in the kit.
Wow. Yeah.
So I'm like,
That's nice.
it does not drive straight. It pulls to the right.
Oh, really?
I'm like, I don't know why it doesn't drive straight, but it doesn't.
That's why you can take it to the gym. Oh no, we don't have a gym.
We can
could
take it
take it to the
outside or
big gym.
something.
Yeah. Yeah.
So, but yeah, so they've got these little things. Yeah, when we were doing it, so they're like, basically our goal over the summer, and not the conference thing in the summer, was to make one that went the farthest distance.
Yeah. Yeah. And you all have the same kit?
All had the same
Yeah.
kit. And it was like, some of y'all people have never built a car before, and it shows.
Some of you people have not had hands-on. All you do is the math.
Like, some of you people have never built a car before, and it shows. So, I mean, it's like, it's not that hard. But we only got 15 minutes to build it.
Wow.
Yeah, because we had to do it in the whole thing. But yeah.
Yeah.
So we're going to see what we get.
Yeah. Yeah. That'll be
It'll be very entertaining. So yeah, so basically I gave them 2 sides. I gave them 4 of these pieces, 4 sticks that are a foot long.
Yeah.
4 wheels, 2 big rubber bands. I give them some little rubber bands.
Yeah.
They get 4 bolts, 4 screws.
That's pretty cool.
4 wheels, a little hook, and a little piece of rubber.
Would
tubing.
you have them recycle that? Like, take it apart and let's do it again for next year?
No.
No? Because that's a lot. Because if you're going to buy a kit
these, I mean,
each
like,
year,
because I won these, so I'm giving them to them.
Yeah. I was going to say, if you did that for each year, it would depend on how much they were.
Yeah.
Yeah, because they look expensive. Of course, they always screw the schools over, so.
Well, I'm going to look. I think it's Arborside, which is cheaper.
Yeah.
So.
Yeah.
So I'll look and see. Because these are, well, yeah, they're not like, super like, oh, here's the instructions on how you build a car.
Yeah.
They're fairly intuitive.
Yeah.
So.
Yeah. They're pretty cool.
They're good.
So why the tall? Is that just for the rubber band attachment or what?
Yeah. This is actually so that I can, like,
Can you modify how far it's going to go to? Or
and how fast it's going to go. Yeah.
Yeah.
So. We'll see.
So they could figure out, well, which one's the fastest.
Yeah, which
Or
one's the
they could-
fastest,
Yeah.
or how do you make it go farther?
Mm-hmm.
You can get like other things that attach, like you can get gears that go on these.
Yeah.
So you can go into how gear ratios work
Yeah.
and
Yeah.
all of that stuff.
You good, Nicole?
But
You good?
I just finished one paper, so
Okay, that's pretty good. No homework then?
no homework for algebra 2, but homework for that one.
you
It's not really homework, it's extra credit, but
Hey, do
it's
it.
a whole 100.
Oh my gosh,
so
yeah.
I'm like, yeah, I'm doing it.
Yeah.
do it. Yeah, no, totally do it.
I gotta finish this for DAP now.
Ugh, have fun.
Yeah.
So, but yeah, so thought you'd appreciate seeing the
I
little
like it.
kits. Isn't it cute?
Yeah.
They are cute, but it
Yeah.
pulls to the right, and I'm not sure why. Maybe I just need to make sure that it goes like. It's like, how do you make sure that it doesn't pull to the right?
I think it's just going to be how precise it is put together.
no.
Distances or between the wheels and stuff, maybe.
Maybe, yeah.
Yeah. Okay. So let me get this one. So for percent to mass, mass to mole.
That's it.
Okay. So once you have moles, then you're going to take those moles, and whichever mole is smallest, you're going to divide by the smallest. So it's divide by small. And then finally, you're going to multiply until you have whole numbers of everything. Multiply till whole. And we'll do some of these in class so you know what it is I'm talking about.